Okay, I would like to work on a homework problem. It's an application problem using the graphing calculator. I have a TI 84 plus. So if you don't have that model, you can maybe find a YouTube video that will help you with polynomial regression. So I'm going to go to the assignment. First, I need to share my screen. And let's see here. So we are doing problem 19 from section 4.2. It says we're given a table and it lists the number in thousands of people in a region over 100 years old for selected years. It says to use regression where X is the number of years after 1960 to find a polynomial of degree 3 that models the data. So a degree 3 polynomial is cubic. So I'm going to go ahead and enter in the data, and I'm going to stop sharing so you can see my calculator. So you're going to go to your stat and you're going to edit. And then for list 1, we have the year 1960, 1970, 1980, 1990, and 2000. But we don't want to put those numbers in because it says X is the years after 1960. So for 1960, we're going to put in 0. And then for 1970, we'll put in 10. And then 1980, we'll put 20. And for 1990, will be 30. And then finally for 2000, we'll have 40. Okay, so that is our first list. Now I'm going to enter in the Y values that correspond to those X values. And I have 2, 6, 14, 36, and 74. Now, to get the function for the regression, we're going to go back to our stat, and then we're going to go over to the calc column and then down. Notice number 6 is cubic regression. So we're going to select 6, and then we're going to go down to calculate. And we're given some values, A, B, C, and D. Now, I'm going to go ahead and share my screen, and you can see how those values are going to be entered. So back to the homework. Here's our function. So A is the leading coefficient, then we have B as the coefficient on X squared, C is the coefficient on X, and D is the constant term. It says round to 6 decimal places as needed. So I'm going to start with my first number that I got on my calculator, and I got 0.001. Hold on, I messed up. Let me just go back to that. Sorry. Okay, so A is 0.001. B is negative 0.001428, but I'm going to round up to 9 because we have a 5 after that. So we're going to enter in negative 0.001429. I'm rounding up because there's a 5 after the 8. And then the next is our C value. That's going to be 0.257143 when I round it up. So we have 0.257143. And then the constant term is going to be 2.0 2.11428 when I round out. So that is 2.11428. Now, one time when I did this problem, I got I had the number in exponential notation. None of these numbers are listed on the calculator in exponential notation, but that is a possibility. So if you get an incorrect answer, make sure you're not overlooking if your number happens to be in exponential notation. But I think I've entered these correctly. Let me give one more check. 429, it looks good. 257,143 and 2114286. I think that's right. All right, now we're supposed to pick which one is the graph. So you're going to want to go ahead and plot your points along with the curve. And so if you go back to let me share my screen. So, or stop sharing, I should say, so you can see the calculator. So we're going to go second function to stat plot here. And we're going to turn our plot on. So we're going to press enter, and then we're going to select on. And now the stat plot is on, so we can go ahead and graph it. Oh, I need to adjust my window. I forgot that part. So going to the window, our data ranges from in 1960 to 0. So I'm going to go to -10, and then 2000 is 40. So I'm going to go up to 50. So -10, and then the max we'll say is 50, and we'll make the scale 10. And then for the Y values, it looks like it ranges from 0 to 80. And so we're going to go, let's see, 0. And then we're going to go up to 80. And 10 again. All right. So now we're going to graph. And there you can see our plot. And let's go ahead and graph the curve. Now I need to go to the Y equal here. So I'm going to enter in the equation. So we have 0.001 and then x to the power of 3. And then we're going to subtract 0.001,429 x squared. So we're going to take x and then square it, and then plus 0.257143 plus 0.257143, and that's times x, and then finally plus 2.114286. Okay, so we've entered, and now we're going to go ahead and graph. And you can see we have a really good fit for our line there. All right, so let's see which one is the correct choice for that. I think A looks like the correct choice there. Now we're going to find out in 1992 how many thousands are going to be. So that is, N is in thousands, and that's the number of people in a region over 100 years old. So in 1992, that's 32 years after 1960. So I'm going to use my trace function. And, oh, one more thing. I'm not able to trace yet. I need to turn off my stat plot so it knows which function I'm tracing. So I'm going to go back into stat plot. So second functions, and then I'm going to turn off my plot. So we're going to press enter, and then we're going to go to off, press enter. Now it's off. So now I can go back to graph, and you can see I don't have the scatter plot there anymore. So I'm going to go ahead and select trace, and I want to enter in 32 and then press enter for X. And it gives me Y equals 41.647. And it says, do not round until the final answer. So I'm not sure. I'm going to try 42. It says do not round, but I'm going to try. I'm not sure what they meant by that. So I'm going to try 42 because I am rounding. And I got it right. Okay. So I'm not sure why they were giving that. I think if you take it, oh, I know what it is. If you take your 32 and plug it into this equation here, then they want you to round it after you do all these calculations. They don't want you to round it, after you plug it in, then round it. But I wasn't doing that. I was using the calculator to give me the answer. Okay, that's why. All right, now we want to know what is it in 2010, and 2010 would be 50 years after 1960. So I'm going to hit the trace button again, and I'm going to enter 50 and then press enter. And I get this time 136.39. So rounding down is just 136. And I should probably, oh, I didn't show you how to do that, but here we go. Okay, and now it says the estimate for 1992 is, let's see what the drop-down menu says here, greater than, the same as, or less than the actual value for 1992. So the actual value, I'm not sure what they mean by the actual value, because we don't really have an actual value. The estimate for 1992, honestly, I don't know what they're asking here. I guess I could guess. I have 3 shots. Oh, the estimate for 1992. Well, we got for 1992, what did we get? We got 42,000, and I rounded up to get that. Is that what they mean? I really don't know what they mean. Are they talking about the rounding? I rounded up to get this. So this is less than or greater than. Let's try greater than. I honestly don't know what they mean by this. And this one I rounded down. So I'm going to say the actual value. Wait a minute. Okay. So I'm trying to remember, for 42,000, I rounded up. So this is greater than, and here I rounded down. So it's going to be less than. Okay, let's try that. I wasn't expecting to get that right. I honestly don't know what they're asking me for that. I do know that in part D, the estimates, let's just switch it then, less than, greater than, let's just switch it. Okay. Same as, I don't know. Oh, got it right, just by guessing. Okay, sorry, I'm not very helpful for you on that problem. The last one, the estimate for 1992. Notice that 32 is inside the range of our data here. So 1990 is the year is 30 years after, and 2000 is 40 years after. So 32 lies between these 2 years. The 1992 lies between these years. So it's inside, that's interpolation. And then, and the estimate for 2010 is going to now be outside, because this goes up to 2000. So that's going to be extrapolation. So when your estimate is inside the data set, in between the given values, then you know you have interpolation, and if it's beyond, it's extrapolation. So, all right. I hope this helps you get through this problem. Some of these problems, these application problems, can be kind of tricky. So, and if anybody knows how to do or what they were asking on this line here where I had to guess, please email me and let me know. I would love to be able to update this video because I really don't understand. All right. That's enough for this video.